Hello everyone, our topic is 2.5 Derivative Rules and Rate of Change. The derivative of a function of a real variable measures the sensitivity to change of a quantity, which is determined by another quantity. Derivatives are a fundamental tool of calculus. The expression d dx means to differentiate with respect to x. The most common derivative d dx of y is usually as dy dx. In order to find derivative, there are 5 derivative rules we have to remember. The first one, power rule. D dx for x to the n power is always equal to n times x to the n minus 1 power. The second one, constant rule. If c is any constant, d dx c is 0. The third one, scalar multiple rule. If c is any constant, d dx for c times fx is equals to c times f, the derivative of fx. This will be talked about later in 3.2 of product rule. The last one, sum rule. d dx for fx plus gx is equal to derivative of fx plus the derivative of gx. Next, we're gonna talk about higher order derivatives. Since the derivative of a function is not the function, we can repeat the differentiation process to find the derivative of a derivative. Next, we're gonna talk about rate of change. That's the meaning for slope-based rate of change. There are two rate of change. First one, average rate of change. It's the slope between 2 points. It is y2 minus y1 divided by x2 minus x1. Another one, instantaneous rate of change. It's the slope at a single point. It is usually found by using a derivative. Last, we're gonna talk about use in real life. Derivatives are constantly used in everyday life to help measure how much something is changing. They are used by the government in population census, various types of sciences, and even in economics. Derivatives help us understand how large things are made from small things, how a curve is made of multiple infinite straight lines. For example, if you run a business, derivatives can help you decide what quantity you should sell. And whenever you want to know how quickly some quantity is changing, you are basically taking its derivative. And last, suppose a large building. Now you want to know how far it will bend if there is a hurricane or a storm. This is fairly easy. You just need to take the first derivative of the force the wind exerts on the building. But if in that situation, I hope you don't just stand there and watch the building and calculating the derivative. Here are some examples. Fx equals x to the fourth power, and we can apply the power rule. D dx x to the n power equals to n times x to the n minus 1 power. So we can solve for 4 times x to the third power. So always remember that the power have to minus 1 when you're taking the derivative. And second question, find the rate of change of y equals x squared minus x over x squared at the point of 1, 0. So basically we can, this one, we can use the knowledge from limits. We have to factor it out. So y is equal to x times x minus 1 divided by x squared. And then we can factor out the x from the top and from the denominator and numerator. So we get y equals x minus 1 over x, and which is 1 minus 1 over x. And then we can write it to y equals 1 minus x to the negative 1 power, and then we can apply the power rule. So again, so 1, the derivative of 1, a constant number, is always 0, so it is 1, so it is negative x to the negative 2 power, and then we can plug in the point 1, 0, so f derivative 1 equals to negative 1 to the negative 2 power, and we can see the answer is 1.